At this 2014 IMTS, NTK formally introduces a new insert category for high-temperature alloy machining called Bidemics. Bidemics is a proprietary group of advanced composite cutting tool materials. JX1 and JP2 covers a wider range of applications than any current whisker, Cylon, CBN, and carbide. JX1 grade machines non-scale roughing and finishing of high-temperature alloys. JX1 has four major strengths when machining high-temperature alloys. Number 1. Longer tool life than whisker ceramic. Number 2. Up to 480 meters per minute capability. Number 3. Machine's latest high-temperature alloy materials. Number 4. Provides superior finishes on machined parts. JX1 can achieve longer tool life with the same cutting conditions as whisker ceramic. In a laboratory trial on Inconel 718 material, running at 360 meters per minute, whisker ceramic starts getting wear on the first pass when sparks occur. However, JX1 easily completes the whole machining without sparking. On the second pass, whisker ceramic wears continuously with increased sparking towards the end of the pass. JX1 sparking starts only at the very end of the second pass because of its superior wear resistance. Insert wear after the trial verifies that JX1 demonstrates extremely better wear resistance and shows much better notching resistance than whisker ceramic. JX1 could have continued to run a third pass with the edge showing little wear. This is an actual field test result on Inconel 718 material with no scale running at typical whisker cutting parameters: 240 meters per minute, 0.2 millimeter per revolution, and 2 millimeters depth of cut. Results show that NTK Bidemics JX1 grade had more than 3 times longer tool life than whisker ceramic. JX1 can machine up to 480 meters per minute on non-scale high-temperature alloy machining. At the speed of 480 meters per minute, on Inconel 718, whisker ceramic is already laboring, showing excessive wear, and sparking occurs immediately. JX1 has smaller wear at the same high speed. JX1 shows no sign of sparking, which indicates greater wear resistance versus whisker. Whisker ceramic broke during the first cut due to lack of wear resistance. JX1 demonstrates more wear resistance and the capacity for higher productivity. Insert wear after the trial verifies that JX1 demonstrates high cutting speed capability, which contributes to dramatically increased productivity. JX1 has the capability to double cutting speeds and increase productivity. This is an actual field machining test on an aircraft engine shroud. Material is Inconel 718 and cutting speed was 390 meters per minute versus whisker at 190 meters per minute. JX1 increased the cutting speed by 150% over whisker ceramic in this production application. An additional advantage of higher cutting speeds is that chips break into small and manageable segments. Whisker's slowest cutting speeds causes typical elongated chips. JX1 can machine newer compositions of difficult-to-machine materials, like powder metal heat-resistant alloys. This is the actual results of JX1 machining a turbine disc. Material is Rene 104. Rene 104 is a high cobalt aerospace alloy, one of the most difficult to machine with any existing insert grades. JX1 achieved 4 times longer tool life than Whisker ceramic in the same cutting conditions. JP2 is a coated, multi-tipped insert for high-speed finishing of high-temperature alloys. 4 mm brazed tips provide greater machining stability. JP2 has 3 major strengths as the grade for high-temperature alloy machining. Number 1, faster speed capability. Number 2, significant increased wear resistance versus CBN. Number 3, superior surface finish on machined parts. JP2 can finish high-temperature alloys at speeds up to 10 times faster than carbides. JP2 can increase productivity and reduce manufacturing costs, production downtime, labor costs, and investment in new machinery. In the finishing application on Inconel 718, at the depth of cut 0.28 mm per revolution, JP2 can machine at the speed of 240 meters per minute versus the typical carbide cutting speed of 30 to 36 meters per minute. The edge wear of 4 insert materials are compared at the same cutting parameters when machining Inconel 718. JP2 shows the best wear pattern even compared to CBN and Whisker. Obviously, carbide can machine at 240 meters per minute. This is the actual results of JP2 machining a turbine disc, material Inconel 718. JP2 could easily machine at the speed of 240 meters per minute, where carbide can only machine at 21 meters per minute. Production increased more than 1,000% by only replacing carbide with Bidemics JP2. JP2 shows superior wear resistance compared to CBN or carbide. JP2 excels with better surface finishes. JP2 shows better wear resistance than CBN at the same cutting parameters. Compared with carbide, JP2 had better wear resistance and increased speed capacity. JP2's outstanding wear resistance and notching resistance results in a workpiece surface finishes consistently superior to either CBN or carbide. NTK is entering into a new era of high-temperature alloy machining. NTK's Bidemics is not carbide, not ceramic, not CBN, this is Bidemics.